second. All right, so our first speaker, it can be hard to not build single-page apps these days without all the JavaScript frameworks. But trying to secure these apps is another page entirely. But fear not, Otto is here. Woo!
All right, good morning, everyone. All right, welcome to Erie Day of Code. You know it's going to be a good conference when I'm the first speaker, so it can only get better from here. So I want to thank Matt, Luke, and all of the organizers for bringing me out here and bringing all of you guys together for another wonderful Erie Day of Code on May the 4th. Let's do it. So my talk today is titled, A Token Walks into a Spa. Now, how many of you guys build or, currently or in the past have worked on single-page applications? Okay, so about half. And how many of you guys have worked with Json Web Tokens? Okay, about to say the same crowd. So today, my talk is really about securing single-page applications. And for those of you guys that already work in this field, you might learn a new thing or two. And for those of you guys that don't work with single-page applications, you're going to walk away with some really new insights that'll hopefully get you to want to work with single-page apps. So to kick things off, my name is Otto Kukic, and I work as a developer evangelist for a company called Auth0. And what we do at Auth0 is essentially identity as a service. So we take care of all of those pesky login pages, authentication, authorization, use cases that no developer really wants to build. So we kind of try to make that easy for developers. And I don't think I'll have time to take questions after the talk, but if you guys want to follow me on Twitter or find me after the talk and just ask any questions you want or give me feedback, I would really appreciate it. With that said, let's get into the talk. So single-page application security best practices. So for those of you guys that haven't worked with spas before, these apps built with frameworks such as Angular, React, Vue, they live entirely in the browser. And when it comes to the browser, this is really a public sandbox where you can't really have secret API keys. You can't have private data because no matter what you do, you can minify your code, you could try to obfuscate it, you can try to hide it, but a malicious actor wanting to really, get at your data is going to be able to download it, eventually, reverse engineer it with enough time and steal all of your codes. So with that in mind, a lot of companies these days are building, single-page applications, and a lot of them are building secure single-page applications. So there must be some security best practices, right? Unfortunately, there are not. So you really can't have any private data, any secure data in the browser that you don't want leaked, that you don't want somebody else to be able to find out. So how do we get around that? How do we build truly secure single-page apps for the modern world? Well, if we take a look back, 20 years and even up to now, the way that we typically have built applications and web applications specifically are that we would have this giant, secure sandbox, and I'm just going to use the color green. And then we had our public-facing interfaces, typically the browser, where the users would interface with our application. So again, I told you I'm not a very good speaker, and today's May the 4th, but I'm going to use the Avengers as the demo going forward. So say you had a web application called Avengers.com that allowed you to talk to the Avengers, send incident reports, and stuff like that. So a user would come to Avengers.com, and they might come to the home page, and when they do that, you would make a request to your backend server. Now, your backend server is fully secure. You might have secret API keys there. You might have all sorts of code that's not publicly available. So you would investigate this request, see that, determine if it's a valid request or not, render the page server-side, so render the presentation layer, and then finally send it back to the browser. Now, if the user needed to be authenticated to access any of the features, they would log in, provide their username and password credentials. Once they did that, you would typically set a cookie in their browser, a session ID, and every single time they made a subsequent request, you would look at this session identifier, make sure that the user is still logged in, has a valid session, And if they do, if they did, you would render the page again server side and send it to them. And this really is a tried and true method of doing web security. And there are a few security best practices there, concerning cross-site scripting, cross-site request forgery, and many of these are really solved issues. So if you're building traditional web applications, you're in a good place. But over the last 5 or 6 years, we kind of stopped developing these monolithic apps that had the back end and the front end as one giant application. So now, if we look at a modern architecture, we see that the secure sandbox has shrunk down a little bit. And our public space, our browser, has taken on a much bigger role for better or worse. So now, instead of having, Avengers.com, you might expose a service that exposes your logic at, say, api.avengers.com. And this would allow any public client to be able to hit api.avengers.com with a RESTful response request, and then you would send the response. And the presentation layer and the logic of your application would live entirely in the browser. So you could use a framework like Vue.js, Angular, React, roll your own, or even jQuery if you're old school. And your application entirely, all of its functionality would live in the browser publicly. And being the good developers that we are, we typically don't only build for a single client anymore. So we might be thinking of also developing a mobile app or an IoT device such as a Google Home or Amazon Echo. And ideally, we would want all of these dummy clients, these public applications, to talk to a singular source of truth, singular backend. And the way we do that typically these days is via RESTful APIs. So you send JSON requests, you get JSON data back as a response. And you could do this with REST, you could do it with GraphQL, you could do it with gRPC, or again, if you're old school, you might be using SOAP services. So it's all kind of the same. But really what we're concerned with when building single-page applications is this transmission layer. And since we can't have private data within app.avengers.com, we have to have a method of being able to talk securely to our backend to get the private data. And how do we do that? The answer, of course, is Json Web Tokens. And for those of you guys that are just finding out or just hearing about Json Web Tokens, I'll give you a brief definition. Json Web Tokens are an open industry standard method for representing claims securely between two parties. Now, if that wasn't confusing or didn't really get you to understand what it is, let's take it a step further and show you what a Json Web Token looks like. So yeah, still doesn't help that much, right? And when I was first learning about Json Web Tokens, I kind of went the technical route of reading the RFC and downloading a bunch of libraries and trying to understand how this worked from a technical standpoint. And I ran into a whole bunch of walls and a whole bunch of roadblocks. And so what I want to do for you guys today is show you how token-based authentication works in the real world, and then kind of tie it back to Json Web Tokens in modern single-page applications. And then just a side note, Json Web Tokens can be referred to as Json Web Tokens, JOTs, JWTs, so I'll use those terms interchangeably from here on out, just to kind of keep it brief. So the example of the real-world token-based authentication we're going to use is a driver's license. So here we have Thor's fake ID. And the question that I want to answer is, how is a driver's license like a Json Web Token? And the way we're going to do this is we're going to deconstruct a Json Web Token and apply it back to a driver's license. So the first part every Json Web Token has to have is a header. And the header really just tells you what you're working with. So let's put our driver's license on the left and our Json Web Token on the right. And let's examine what the header would be for a driver's license. For a driver's license, the header would be that the fact that it is a driver's license, everybody has seen one or has one, kind of knows what it looks like. This particular driver's license literally says on it that, hey, this is a driver's license, and the issuer of this driver's license is the state of New York. If we look at our JSON Web Token, the header is this very first part in green, starting with EY and then ending in J9. And this is really just a base64 URL encoded string so that we could pass this data between the client and server easily over HTTP. But if we were to decode this piece of code or this jumbled up string, what we would get is a JSON object that has two properties. One ALG that stands for algorithm and one TYP that stands for type. And the algorithm is what the token is, what hashing algorithm we use to sign the token, and we'll get to that in just a little bit. And the type is, what you're working with. And in 100% of the cases, if you're working with JSON Web Tokens, the type will be a JOT. So pretty simple, and so far I think the analogy works. Now we get to the really interesting part of the JSON Web Token, which is its payload. And the payload of the JSON Web Token is really the data and claims that you want to transmit securely between the front end and back end. So again, if we put our driver's license and JSON Web Token up on the screen, let's look at the payload for the driver's license. Well, we can kind of look at the payload as the driver's picture, their name, their address, their demographics, such as their eye color, height, and other attributes like that. And then finally, their restrictions. So what type of vehicles can they operate? And JSON Web Tokens kind of work much the same way. The payload is this part in blue. And the payload, again, is just a base64 URL encoded string. And if we were to decode this string, we would see that, again, we get a JSON object back that has a couple of different properties. And here we have 4 properties: sub, given name, family name, and then the admin property set to true. And when it comes to the payload of JSON Web Tokens, there are really 3 types of claims you can make. The first type of claims are what is referred to as reserved claims. And these are claims that the folks that came up with the JWT standard said, we want these to be included in every token for, best practices. And those claims are claims such as this subject claim SUB, which is essentially, the user identifier, the user ID. Other claims here, there's only about 10 or 12 of them. One of them is IAT for issued at when the token was created. ISS for the issuer, so who created this JSON Web Token, and then finally EXP for the expiration date of the token, which is perhaps its most important attribute. Now, the other 2 types of claims are private and public. And when it comes to public claims, these are really meant for API interoperability. So the public claims that I have here are given name and family name. So if you were using JSON Web Tokens to transmit user identity across different applications, across different APIs, using kind of standardized notations, instead of first name saying given name, instead of last name saying family name, just kind of makes it easier to interoperate your application, your API with others. And a lot of these claims, they're not registered with the RFC, with the JSON Web Token RFC, but they are registered with the IANA, and there's about 50 or 60 of these. So again, not an exhaustive list, not a really huge list, but just a list that'll help you interoperate your API with others. And then finally, we have private claims. And private claims are really specific to your application domain, and these claims can be anything you want. So an example of a private claim I have is the admin property being set to true. Now, I just represented this as a Boolean true or false property or value, but I could have done this in any way. I could have said, admin 1 for true, 0 for false. I could have, instead of saying admin, I could have said, roles or permissions, and then passed in an array of data with, the roles and permissions that this particular user would have. It really doesn't matter. It's how you want to do it and what you feel comfortable with. And as long as it's valid JSON, you can put it in the token. Now, before I move to the third part of the token, one thing that I really do want to point out is that both the header and the payload of the JSON Web Token are just base64 URL encoded strings. They're not encrypted. They're not secured in any way. So if anybody were able to steal your token, they could easily decrypt it and see what's held within it. So you don't want to put any sensitive information in the token, such as social security numbers, credit card numbers, or really anything that is really private and that you wouldn't normally display within a SPA application. So with that said, let's look at the last part of a JSON Web Token, which is its signature. And what the signature is it helps verify and validate the integrity of the token. So if we put our driver's license and JSON Web Token up side by side again, let's look at what the signature would be for a driver's license. Typically, it's just a UV light hologram that's embedded on the driver's license when it's issued by the DMV. So this allows parties like the TSA or wherever you need to present your driver's license, they could kind of look for this UV light, and if they find a hologram and know that it's intact, then they can assume that this driver's license is valid. Now, for the JSON Web Token, the signature is this last part here in black, starting with UL and ending in GI. And to get the signature, what we do is we take the base64 URL encoded header, the base64 URL encoded payload, and then we, in the case of the HMAC SHA-256 hashing algorithm, we provide a string-based password. So here we have the password being Loki sucks. So if we were to sign this particular token with this password and send it to our backend would validate or verify that the token was signed with the password Loki sucks. And if it wasn't, it could assume that this is a forged token, this is a misplaced token, and not send the private data. But if the token was signed with a specific password or string, then it can assume that the token came from a trusted place and it's safe to send the private data or whatever the user requested. So HMAC SHA is just one of the many different hashing algorithms, and probably the one that's the least secure but easiest to demo. The other one is RS-256, and in that algorithm, you actually use a private key to sign the token, and you give out public keys that can be used to verify the integrity of the token. So I'm happy to talk to you guys offline about how that works, but for now, we'll move on. So let's see how we use token-based authentication in the real world, and then we'll tie it back to our single-page applications. And since we are talking about driver's license, let's kind of tie it back to the title of the talk. A token walks into a spa or bar. So let's say Thor is really happy with the numbers that Avengers pulled in last weekend, and he wants to go and celebrate with the rest of the Avengers. So he comes down from Asgard, and he wants to go to a bar. Well, he doesn't have a driver's license, so he'll need to get one. And the smart thing to do would be for Thor to go to the DMV, spend 5 or 6 hours waiting, filling out a bunch of different information to verify and validate his identity. And once he did, he would be issued a token, in this case, a driver's license. And he would hold on to that driver's license and use it from there on. So when Thor got to a bar, before walking in, the security guard is going to ask him, to see and verify his driver's license. So of course, since Thor has it, he's going to give his driver's license. The security guard is going to verify that this is a valid driver's license issued by the state of New York. It has the UV light hologram. Everything is good. So he's going to give Thor the thumbs up and let him walk inside. Now, when Thor goes to purchase a drink at the bar, the bartender is going to ask him to see his driver's license again, and the bartender is going to verify that the driver's license is still valid, is still intact, it hasn't expired from the time that he walked in. If it's all good, he'll be able to get his drink. But knowing Thor, I don't actually know him, but I assume he wouldn't be the type to spend 6 hours at the DMV. So he might go to a shady character, and instead of waiting and filling out a bunch of information, he might just give this guy some money, and he'll happily forge him a valid-looking JSON Web Token or driver's license in this scenario. So, it looks like a driver's license. It has the same info that a driver's license would have, but when Thor goes to enter the bar and the security guard asks him for his driver's license, he'll give it because he has it. But when the security guard goes to verify it, he'll see that this driver's license has a whole bunch of falsified data. It doesn't have the right UV light hologram. And he's going to tell Thor that, you can't get in, buddy. So that's how token-based authentication works in the real world. Now let's tie it back to our single-page applications. So again, we have our reduced secure sandbox, and then we have our application living in the browser. So let's put those up. And say a user were to come to the application and try to talk to the Avengers API and send an incident report. So, they try to hit the version 1 SOS endpoint, and at this point, they're not logged in, they're not authenticated. So the API server is gonna first look at this request, see that it doesn't have a valid JSON Web Token or a JSON Web Token at all, and it's just gonna respond with a 401 saying, hey, you're unauthorized, you can't do this, please log in. So the next thing the user will do is they are going to hit the authentication endpoint, provide their username and password credentials, and log in. And once the server can verify their identity, it knows who they are, it's going to issue a JSON Web Token to the front-end application. Now, as an aside, the JSON Web Token standard doesn't really have a logo, so I use the Japanese emoji for open for business. So that's just a fun fact. So what's going to happen when a user logs in, they're going to get a JSON Web Token, and they're going to persist it somehow in their single-page application. And now they're going to be able to talk to that SOS endpoint, but this time, instead of just making a request, they're going to make a request and append an authorization header in the format of bearer and then the JSON Web Token that they received from the server. So now we're making a request, we have a JSON Web Token, our backend server is going to, again, check for the existence of the token, then it's going to verify the integrity of the token, make sure it has the right signature, and then it's also going to validate the claims within the token to see that it came from a trusted source, it has the right roles and permissions, it has the right data, and only then will it respond successfully saying, okay, we received your request for help, and we're going to assign Hulk to it, and we'll take care of it. So that's really from an architecture standpoint what this looks like. If we were to briefly look at a code example, here in my single page application, whether it's React or Vue or Angular, I'm using the Axios HTTP library and making a post request, and so the first parameter I have is the API that I'm calling, so whatever the Avengers API is, and then the SOS endpoint. The second parameter is the data that we're passing along, and here we're just saying help, Thanos is coming. And then finally, the third parameter is going to allow us to work with the request and modify it. So all I'm doing is appending an authorization header in the format of bearer and then appending the token with it. And then once this request completes, I'm just console logging the response here saying that Hulk has been assigned to this. So that's the simplest use case of how JSON Web Tokens work. But the good thing about JOTS is you can really, your API server doesn't have to be the one to issue these tokens. So let's look at a bit of a more advanced scenario where we have our secure API backend, we have our single page application living in the browser, and now we have a third authorization server that its only concern is dealing with logging users in and issuing JSON Web Tokens. So we have our server, our application, and now we have a separate domain, a separate application called login.avengers.com that is going to take care of authenticating users. And I'm just going to use the Auth0 logo in here, but this is a fairly generic authorization server. And everything you learn here is applicable to whatever platform you use. And if you guys have used Google in the past couple years, whenever you go to log into Google, you first go to accounts.google.com, log in, and then they redirect you back to YouTube, Gmail, Calendar, whatever app. So this is kind of that architecture scenario. So what would happen in this case is the user is going to land in the browser in your Angular or Vue or React application, and they're going to click the login button. And once they do, they're going to be redirected to login.avengers.com, and they're going to provide their set of username and password credentials. Once they're authenticated and once the server has logged them in, this authentication server is going to make a callback to your single-page application with the JSON Web Token. And now, at this point, your API server, your resources server, isn't even aware of this transaction. It's not concerned with it. It doesn't care. Because so far, we're not even talking to api.avengers.com. But now, since we are logged in, we have a valid JSON Web Token, we can go ahead and make a request to that SOS endpoint or any endpoint within the Avengers API. And since we do have a token, when the request is made, the server is going to verify that this token came from login.avengers.com. It has the right issuer, it has the right data. And if everything matches up, it's going to send back a successful response to our single page application, and the single page application is going to render the presentation logic. Now, this is a bit of a more advanced scenario, but also the question that I typically get from a lot of folks that are just starting out or learning about JSON Web Tokens or have been doing it for a while is, where do we store this token? So before I answer that question, let me ask you guys, how many of you that use JSON Web Tokens store them in local storage? Okay, a few hands. What about session storage? No hands. What about cookies? No. Okay, great. So you guys are doing good work. So basically, you want to persist this JSON Web Token somehow, but you don't want to store it in local storage or session storage, because if you become susceptible to like a cross-site scripting attack, somebody could steal this JSON Web Token and essentially impersonate your user, and that would be a very, very bad scenario, because these tokens contain so much information that it's very easy to impersonate somebody and do bad stuff until the token expires. But if you don't store the token in local storage or session storage or persist it somehow, when the user inevitably refreshes your page or opens it up in a new tab, your user is going to be logged out. And that would be a really crappy experience as well, because you don't want to log the user, force the user to log in every single time they refresh the page. So how do we get around that? Well, we'll go back to this three-pronged approach again. And basically what we're going to do, when the user goes to log in at login.avengers.com, when they're successfully authenticated and we can verify their identity, before issuing the token, we're going to set a session identifier on login.avengers.com. We're going to set a cookie that says, hey, this user's logged in, and then we're going to issue the token back to your single page application. And within your single page application, you can persist this token in memory. So if you're using React, you might store it in Redux, or if you're using Vue, Vuex, or whatever data store or state management library you're using, you can store the token there and be fairly safe. And then the process for talking to the API is pretty much the same. Every time you make a request, you pass the token along, and the server verifies it. Once it verifies all the data, it sends the response back. But now, since we are storing this token just in memory, we still have that same problem where the user is logged in at login.avengers.com, but our app.avengers.com domain can't share this cookie and can't really do much with it. So again, if you refresh the page or open it up in a new tab, your user in your SPA application is still going to be logged out and be forced to log in. So how do we get around that? The answer, again, or newly, is that whenever your single page application is loaded, what you would do is you would make a silent authentication request to your login server, to your authentication server, and typically this is done in an iframe. So when the page is loaded, you make a request to login.avengers.com. This request is going to check for the existence of a cookie on login.avengers.com. This cookie is going to be verified on the backend to make sure it's still valid, the user has a session, and if they do, we'll just issue a new token back to the single page application. So in this case, it's totally transparent to the user doesn't even see this happen, but now if they refresh the page or open the app in a new tab, they can still be logged in and they can still continue to do all the things that they would expect to be able to do, and which is mainly talking to the API server and getting successful responses back. So that is how we would use token-based authentication in the real world to secure our single-page applications and have the secure transmission layer between the SPA and the secured backend. And if you guys are interested in learning more about JSON Web Tokens, jwt.io is a really, really great resource that's going to allow you to decode JSON Web Tokens, find out all of the different libraries for different languages and frameworks. So whatever framework you're working in, there's probably a library that can help you implement JSON Web Tokens. If you're interested in learning more about JSON Web Token signing algorithms, this bit.ly link, JWT-AGALG, is going to give you a whole bunch of information on the different algorithms, when you should use one over the other, and how to use them. And then finally, if you really want to geek out and learn way more about JSON Web Tokens than anybody needs to, my colleague Sebastian actually wrote a free handbook called the JWT Handbook, and you can find it at bit.ly JWT-book, and this will really go way more in depth onto every single thing JSON Web Tokens are used for, how to use them, the pros and cons, and so on and so forth. So with that said, let's do a really quick summary. Single-page application security is mainly concerned with authorization. So we can't have secure single-page apps. There's really no best practices there. But the thing we are concerned with is ensuring that we can have secure communication between our public application and a secure backend. And JSON Web Tokens are really excellent for this use case. Finally, there are many excellent JWT libraries for all languages and frameworks, lots of HTTP clients for working with JSON Web Tokens on the front end, such as, I showed you Axios, but you can use Fetch, you can use jQuery, you can even use XML HTTP request if you'd like, and it all works pretty much the same. And then finally, a security guard probably couldn't stop Thor from getting a beer, but your server certainly can refuse requests that don't have a valid JSON Web Token. So with that said, thank you guys so much, and here's to a great Erie Day of Code.